Okay, this time we're going to discuss two more problems about implicit differentiation. The first one is to find for the second derivative of y with respect to x. And then the second problem is finding the equation of the tangent line to the given curve, no, at a given point. Okay, let's start with our first example. How to find y prime prime or d squared y dx squared of this equation by implicit differentiation. First, we find dy dx. Okay, and how do we find dy dx? Again, we indicate the ddx on both sides of the equation. X squared plus y squared plus 4y squared, okay, equals ddx of 4. And then the derivative of the sum is the sum of the derivative, right? So the derivative of x squared is 2x. So the derivative of 4y squared, okay, using implicit differentiation, that's 8y to the 2 minus 1 times the derivative of y with respect to x. Okay, so I hope at this point you already see the difference between the derivative of function with respect to x only and function with respect to y. Okay, or when it comes to function with y, you always have dy dx, right? Equals the derivative of 4, which is 0. Then solving for dy dx, you have 8y dy dx equals minus 2x. That means that your dy dx is minus 2x over 8y, which means that dy dx is minus x over 4y. Okay, so after finding the dy dx, we now find d squared y dx squared. Okay, how do we find this? We indicate the operator ddx on both sides of dy dx equals x minus 4y, negative x over 4y. So ddx of negative x over 4y. Now, what is the derivative of dy dx? It's of course the second derivative of y with respect to x. And we apply here the quotient rule, no? Because you have numerator and denominator. So recall the quotient rule. It says the denominator times the derivative of the numerator, which is negative 1, right? Minus the numerator times the derivative of the denominator, which is 4, times the derivative of y, which is dy dx, then over negative over 4y squared. Okay, then you have d squared y dx squared equals minus 4y, this one is plus negative 4x dy dx, okay, over 16y squared. Okay, now we're going to express everything in terms of x and y, so that means that this dy dx should be replaced by this expression here. Okay, so you will have d squared y dx squared equals minus 4y plus 4x times the dy dx, which is minus x over 4y, okay, then over 16 y squared, and that's equal to minus 4y This will become minus 4x squared over, by the way, we cancel this, right? Then over 16y squared. Okay, which is now equal to, combine this as a single fraction, so this is minus 16 y squared minus x squared over y times the reciprocal of this. So this means that your d squared y dx squared is equal to minus, we can choose to put the negative here as a common sign, then 16y squared plus x squared over y times 16y squared is 16y cubed, okay? Which is our second derivative of y with respect to x. Okay, next is find the equation of the tangent line to the curve x squared minus xy minus y squared. This is x squared minus xy, okay, minus y squared equals 1. Let's rewrite here the curve x squared minus xy minus y squared equals 1. Okay, the objective is to find for the equation of the tangent line. Equation of the line that is tangent to this curve. I think this curve is a hyperbola. Okay, so we find the equation of the line tangent to this curve at that particular point. To find for the equation, you remember, you need two things. Okay, first is you need the slope, and second is you need a point. No? Now we already have a point, we need only the slope. How do you find the slope? One of the definition of the slope is that it is the derivative of the curve. Okay, so we find the derivative of this curve first to find for the slope. How? We indicate the ddx on both sides. Okay, and this one here is 2x, okay, minus the derivative of xy. Now we use the product rule here because this is the product of x and y, so the product rule says the first times the derivative of the second. Derivative of y is dy dx, right? Plus the second times the derivative of the first, which is 1. Okay, derivative of x is equal to 1, minus the derivative of y squared is 2y times the derivative of y, which is dy dx by the chain rule, okay, equals 0. And then we have negative 2x minus x dy dx minus y minus 2y dy dx equals 0. We put this together, so factoring out the dy dx, we have minus x minus 2y, then the rest will be placed on the other side, so this negative y becomes y, then minus 2x, then you have dy dx equals y minus 2x over minus x minus 2y. We can actually simplify this further by multiplying numerator and denominator by a negative, so this will become 2x minus y, but the denominator becomes positive na. Okay, so this is your dy dx. This is actually the slope, no, of the line tangent to this curve. of any line that is tangent to this curve. Now, how do you find the slope of the line tangent to this curve at that particular point? At this particular point, okay? The slope of the line tangent to the curve at this particular point is actually the value of your dy dx at that particular point. So that means that we need to evaluate the dy dx at the point 2, 1, okay, which is equal to recall this, right? Okay, which is equivalent to 2 times 2, okay, your x being equal to 2, then minus y, and your y is 1, over your denominator is x plus 2y here, so over x, which is 2, plus 2 times y, which is equal to 1. Okay, so we substituted the point 21 here. Okay, so we obtain this expression. And what is the slope? The slope is, simplifying, you have 3 over 4. Okay, so we now have the slope 3 over 4, and then the point 21. We now find the equation by using this form: y minus y1 equals m times x minus x1, where your y1 is 1 equals m, which is 3 over 4, times x minus x1 is 2. Of course, we can write this as 4y minus 4 equals 3x minus 6. And we can write this as 3x minus 4y. Okay, I choose to put this here. Okay, so I have 3x minus 4y, and then equals negative 4 plus 6, so this is 2. At least we're able to write the equation of the line in standard form. Okay, so this is the equation of the line.